Okay, let's look at the theorem 4. Right? It says that if point C is on the open ray AB, then ray AB and ray AC are exactly the same ray. Right? So since the formal proof is given in the textbook, I'm going to do an informal proof and draw pictures and stuff. Alright, so it says this. Alright, so you have a ray AB. So I'm going to just draw ray AB. Alright, so here is point A. And here's point B. Alright. Then what we're going to do is I'm going to extend it to line AB. So here, I'm going to just extend it. So I'm just going to add this here. All right, you have a line AB. All right. Then we can use D4, ruler portrait, part, I believe it's a part 3. And it says that we get to give 0 coordinate to any point you want. So I'm going to give a 0 coordinate for A. So here. Right? Then any positive coordinate for B. So I'm going to just give 1. It could be any number, but I like 1. So positive number. All right? So this is a setup. All right? So then we look at the C. C is going to be in open ray AB, so it's not going to be at A, but on ray AB here. So a possibility would be either C could be here, right? Which is C is between A and B. Actually, yeah, A and B. Maybe I'll do that. Right, or it could be right on B, so C is equal to B, right? Or here, which is between this condition would be B is between A and C, right? Then using a previous theorem, theorem 3, we can talk about their corresponding coordinates. So coordinate C would be, since C is between A and B, its coordinate, let's see, lowercase c would be between 0 and 1, right? Or if C is equal to B, so then you would have the same coordinate, so C is equal to 1. Or C, between this condition B is between A and C, which means that the C is going to have coordinates larger than the coordinates of B, which is 1, right? But if you combine all three, we know that the C is just some positive number, right? Then let's look at this guy. So let's start with ray AB, right? And then we're going to look at the ray AC and compare these two, right? Ray AB, by definition, we know that it's a collection of points such that it's either x equals A or x is between A and B, or x is equal to B, or B is between A and X. Right? Sorry, just it's dragging. Right? But if you look at this in terms of its coordinates, so I'm gonna, let's say coordinate of x is a lowercase x, right? Right. So if x is equal to A, so x is going to have a coordinate 0, because the coordinate of A is 0, right? And then it's between A and B, then x is going to be between 0 and 1, right? If x equals B, then x is going to be equal to 1, because coordinate of B is 1. If B is between A and X, then X is going to be certainly bigger than 1, right? But you can see that this is a long way of saying, so this is OR, saying that this is going to be a collection of points on line AB such that the coordinates are just positive, because it's 0, between 0 and 1, 1 and the greater than 1. So that's just all positive numbers, right? Real numbers, right? So we came down to this. How about ray AC? And by definition, a ray, it's a collection of points x, either x equals a, right? X is between A and C, right? Or X equals C, or C is between A and X, right? So we have that. But if you describe this in terms of coordinates, you will see that here X equals A, so X is equal to 0. Right, between A and C, so it's going to be X is between 0 and C. C, we know that it's a positive number. If X equals C, then lowercase x is equal to little c, right? And if it's C is between A and X, and then X has to be greater than C. Right, but if you combine all this, this is OR, then you can see that this is just saying that the coordinates are just greater than 0. Right? So either way, you end up with exactly the same set. So therefore, AB, ray AB is equal to ray AC. Right? That's it. I hope that this was clear.